shorten my period, okay, which is good. Okay, I try to also try my best to do as quick as I can, but I also realize my network is not very good, so I'm going to switch off the camera and share the screen, and after the presentation I'll come back to you guys, okay, with my face. So just imagine my face when I'm doing the presentation.
Okay.
In order to save the bandwidth. All right, okay, so let me share the screen first. Okay, can you see my screen?
Yes, perfect.
Okay, so let me do this, and then I also make it bigger. Just hold on for a second. So do you see the whole screen?
Yes.
Okay, good. Then I just kick off. All right. So evening, actually not good night yet, but good evening, everybody. My name is Clara Chung. I'm from the University of Manchester in the UK. My research is definitely focused on health and safety. That's the reason why I got the invitation to do today's guest lecture. And today I'm going to talk about robotics for construction, health and safety. What is the current status? What are the deployment challenges? And what are the potential future development trends as well? Let's see whether I can move on. Okay. So the work that I'm sharing today is related to 3 different projects that I'm running at the moment with different partners, and mainly my partners from Japan, and as well as some partners from European country. And then we are all interested in how to facilitate the robotics adaptation in construction in order to help with the problem, not just productivity, but also health and safety. And then we also work with different industry partners and regulator with all those projects as well. So today's agenda, I'm going to go through, I think 5 different bullet points that I listed here. So it will be around why robotics matters for the construction of occupational health and safety, what are the current status, and then we will dive into look at what kind of robotic types, and then where in the life cycle, the application we have the most at the moment, how the robotics could potentially reduce the health and safety risks, and why it matters, why human robotics collaboration become a topic actually, particularly in construction. And then some of the case example to show you. And then finally, I'm going to talk about the future development trends. And then if we have time, then we can spend a bit of time to do the Q&A before we finish today's session. Okay, so let me go on. So let's build a context, okay, why construction robotics, why we want to talk about construction robotics in the context of occupational safety and health. So because when people talk about robotics in construction, the conversation often starts with productivity. Robots are expected to work faster or more consistently, and sometimes for a longer period than human workers. We are not denial that those are important, okay, when we look at robotics application. But today, as I said, I want to frame this as why, how does that will help on health and safety. So the key issue is not simply whether robotics can complete a task. The key issue is whether the robotics, if we include them, okay, into our operation, whether that would change the risk profile of our work as well. So, for example, does the robot remove a worker from a hazardous environment? Does it reduce the manual handling or prevent us from getting MSD given that the robot is doing the work? Does it reduce the need for workers to inspect structure at height in a confined spaces or near the live traffic, or even under unstable environments? So when we evaluate robotics application in the health and safety context, the question to us is whether what hazard is the robot going to address, who are still exposed even though the robotics is used, who will supervise the robot, and what happens when the robot fails or behaves unexpectedly. That's why robot must be considered as a part of safety management, not outside of it, if we are looking at construction robotics are going to apply on our site in the near future or on the site now. Okay, so given that it really matters, okay, if we increase the adaptation of construction, robotics in construction, we are going to get probably the risk profile is going to change. And then on the other hand, it also helps us to alleviate the health and safety risk. Then let's dive into to have a look at what type of robotics are being used and which part of the life cycle we use it the most. So because of these questions, and because, as I said, those different projects I mentioned earlier, we did a systematic review, looking at mainly academic papers, although we also take a look at the grey literature, but mainly we focus on the academic paper published in the past a few years from 2023 to 2025 in order to give us a flavor of what's going on in the market. Because, robotics application really evolved very quickly. It's meaningless to review the past 10 years because the trend really changed dramatically. So what we found is the evidence actually suggests construction robotics is expanding quite quickly, but the deployment quite even. I'm going to talk about this later on as well. And robotics is increasingly linked to, when you ask people why they're applying robotics, they will say, oh, because the labor shortage, because of productivity pressure, because there's health and safety risk reduction pressure as well. However, most of the application remain very concentrated in the structural construction tasks, such as doing concrete work, mason work, or steel-related activities. So it's mainly focusing on the construction stage. And by contrast, planning, maintenance, demonetization remain far less developed in terms of robotics application, even though we argue those phases may involve even more significant health and safety risks. And another important finding is operator-led workflow still dominant. So even we apply robotics, we are the one who inform the robot what they should do, okay? Instead of fully automate, we are not far away from there. So that means many robots are not fully autonomous. They still heavily depend on human control, supervision, or intervention. So in a nutshell, the current status is not saying that robots are going to take over construction. A more accurate summary, I would say, robot is growing, but it is still very task specific, unevenly distributed, and heavily depending on human involvement in construction. So let me also give you a little bit background, okay, because we always try to compare how come the adaptation of robotics in construction are so slow comparing with manufacturing, even though construction is at a high risk, is much higher risk than manufacturing most of the time. So in manufacturing, because robotics often operate, you can imagine in the factory, it often operate in a very structured, in a repetitive, or in a relatively controlled environment. So the workplace can design around the robot. Materials, your expected materials will arrive in a very predictable position. Tasks will repeat thousands of times by itself, while construction is totally different, right? Every construction site is temporary. The ground condition could change, the weather could change, and then even the access routines could change from day by day. And material could store in multiple different locations. The design information could change. Subcontractor could work in overlapping zones. So that all that means, or that really makes robotic application is not a straightforward task like in laboratory or factory-like environment. The challenge is how when the site is so dynamic, the workforce is also fragmented, and then the environment is so uncertain as well. How can we really make the robot apply on the site and interact with human in a safety manner? It becomes kind of very challenging. All right, so that adds the complexity in terms of the adaptation. Okay, then let me zoom you back to talk about types of robotics that are being used, okay, on the construction site now. Let me minimize this one as well. Okay, so There are 4 different groups when we look at the robotics application in construction. So the first group is around inspection and monitoring type of robots. This could include drones, climbing robots, or unmanned ground vehicles. Their safety value is very clear. They can help to collect data in location where human inspection may be dangerous, such as at height or in confined spaces or near unstable structure. So this is the first category. Then the second category is going to be the physical assistant type, okay? So such as exoskeleton that workers can wear or lifting aids that they can wear. This do not replace the worker, but instead they augment the human capability and reduce the physical pressure on workers. Then the third type is what we call the task automation robots. So that could include drilling robots, welding robots, bricklaying robots, and even 3D printing type of robots. They often used for repetitive or precision-based tasks, which require you to be very accurate. And then while they can repeat 1,000 times to drill thousands of holes, okay? So this is the third type of robotics. Last but not least, the fourth group is around the site logistic robots. So such as the material transport robots, semi-autonomous cranes, okay, which could help to lift up the materials. These are important because actually manual handling and material movement are major sources of physical demand and site coordination challenges that could cause hazard on the site. So a key point is that the same type of robot can have different safety implication depending on the task and the workflow. Just to give you an example, a drone can support safety inspection, but at the same time, they can also do progress monitoring because they're flying around. They just compare the images they took with the BIM model, for instance. Then that will fulfill the need as a progress monitoring. And then they can also do emergency assessment, okay? So the technology could be the same, the robotics type could be the same, but sometimes depending on the task, the safety function could differ. Okay, so let me go to the next. Then you may have a question. Okay, we know what type of robotics, and then we know why it's so difficult when we apply it in construction. Then how can I evaluate, or how usually people evaluate whether a task or whether we should apply robotics, okay, or where we should apply robotics? So in terms of construction health and safety, the strongest candidate based on a lot of different research and papers are the tasks actually with the following 4 characteristics. So first, the task that is high risk, okay, which expose worker to could be severe hazards or risk, okay, that could be a potential candidate. Second is tasks that with high repetition, and the task is very specific, standardized, and repeated. Okay, that could be another parameter that we will use to see whether we will use robotics. Third is physically demanding. Okay, if the task is quite demanding physically, that could create fatigue or MSD, increase the risk dramatically. Then yeah, that is another parameter we could use. The fourth one actually are any tasks actually that require quite accurate, to be very accurate, and then the precision. So where robotics can consistently reduce error or rework or quality related safety issue. So this just gives us a practical rule when candidate tasks are often those that I would say, if a task that is high risk at the same time they are quite highly repetitive, usually we will select those as the candidate to apply robotics on the site. Of course, at the end of the day, it depends on the budget and also depends on the client as well. That is another thing that out of our control to some extent. Okay, so that is around the what kind of task. Then I will also want to talk about because we know that the type of robotics, okay, then how about we zoom in a little bit to look at the entire construction life cycle. I also mentioned it a bit earlier already, but this one is just a detailed picture. We try to draw, making, you can see from the starting point of the diagram, we have planning and design, and then you have move on to the site preparation, structural construction, and then you finish. Then you hand it over to operation and maintenance, and finally you do the demonetization. So we map out what kind of robots are being used in different, what we call the construction life cycle. And then what we found out, as I mentioned earlier, the majority of the robot we apply nowadays is for the structural construction stage. Yeah, we also use it a bit on the site preparation, which is also part of the construction stage. But for maintenance, when you look at maintenance and as well as demonetization, actually we are not doing a lot, and planning and design, we are not doing a lot as well. So we are arguing actually, those are the opportunity. I mean, for the future. Just give you an example. For example, like in maintenance, robot could inspect aging infrastructure without exposed workers to the hazardous access condition. And then in demonetization, actually, robot could reduce the exposure to dust or falling debris and unstable structure of workers if you employ robotics, right? And then going back to the front stage in the planning and in the planning stage, we could use more simulation to help to identify the risk, okay, on the site, and then apply robots to do those kind of risky tasks. So one of the, as I said, those are the probably in the future, there are more opportunity instead of mainly focusing on deploying robots in construction. The other stages of the construction life cycle is worth thinking about how actually to deploy robotics to do the work. Okay, so I think I give you a rough picture on what's going on in terms of robotic types and the life cycle. Now I would like to talk about exactly how actually we are reducing this safety and health risk. I will give you some example to showcase this. So in theory, when we have robotics try to improve the health and safety, there are 4 different ways. I briefly mentioned this already, but this is just a framework for you to think about. So the first angle why robotics could improve health and safety is because of removal. Robots are removing workers from doing those kind of dangerous jobs, okay? Maybe, for example, inspecting a tunnel, inspect a ferry, facade at height, or the post-incident structure, instead of sending workers directly to the site. Okay, so basically you're taking people out of the loop. That is one of the ways why we say robotics application could improve health and safety. The second way, actually, why is because of the reduction. All right, so robot reduce the physical loading or reduce us from doing those kind of repetitive lifting and fatigue as well. So that is a particularly relevant to MSD exoskeleton, robotic type like exoskeleton or material transport system. Actually, it reduces our physical load because of them. Then the third dimension is around detect, because robot can collect the real-time data. For example, just imagine if there's a robotic dog walking around the site, because the robotic dog is armed with all different types of sensors, camera, or scanning system, that could improve our way to get real-time data for monitoring and early detection. And last but not least, standardization, because robot can carry out all those certain tasks with high repeatability that can reduce error and quality issue, and then as well as which could become a safety issue later on. Okay, so those are the reason why we are arguing actually we should try to adopt a bit more robotics in construction, not just for productivity, but also with the consideration of health and safety. So those are the example which actually I talk about a little bit, okay, in early on. So, for example, like application one, when we do inspection and monitoring, and inspection and monitoring are among, I would say, the most convincing health and safety application nowadays. Just like the left-hand side, the drones, aerial inspection can reduce the need for workers to access roof, right? Roof, facade, or bridges, or other high-risk locations. And then the middle example, the climbing type of robot can inspect vertical or difficult to reach surfaces as well. And ground robotics can enter confined or hazardous spaces. Okay, so all this is an example for us for inspection and monitoring type of robot. But safety benefit also depends on the data collection from all these different types of robot. Just give you an example. If a drone collects images of cracks, but the organization actually is lack of a process to reviewing or prioritize or act on those findings, I would say the safety value, even if you apply robotics, it won't work. So I think a key message is not just to deploy more robot as well, is whether at the back end we have linked it with a decision-making system. So robotics become part of helping you to make better decisions instead of treating as a very nice toy or isolated gadgets to play with. Because I also see example, they deploy different types of robots to collect data, but at the end, they figure out, oh, it's so difficult because so much noise, okay, from the data is so difficult to use. All right, so you need to have a pair up capability to analyze those data that could tie up with your decision-making process. Will be my message for the application. So move on, another application is around manual handling and lifting and physical strain. So construction work often involve heavy materials or sometimes require workers to have very awkward posture and repetitive movement. Robots can support workers in several different ways. For example, like the exoskeleton that could provide physical support when doing lifting. For example, just imagine if they need to install, they need to drill holes, okay, constantly. If they don't use robotics, then at least you have the exoskeleton to help you to do the task, lift up your arms, okay, to support you a bit, to carry out those overhead work. And the material robotics, okay, could reduce the needs for people to move around heavy stuff across the site. And robotic plant can also support the remote or semi-autonomous operation in kind of a very high-low task. But I think we need to also evaluate the total risk as well. If you are, industry are interested in applying this kind of robotic. For example, like an exoskeleton may reduce the load on one part of the body, but restricted movement could create discomfort as well, increasing the heat stress if you keep wearing the exoskeleton or affect the balance. So there is balance, okay, we also need to play. So the question is not simply, does the robot reduce one hazard? But the better question, I would say, does the robot reduce the overall risk without creating unmanaged new risk? This is where the ergonomics or the usability, training, and worker acceptance also become critical. Okay, last but not least, give you one more example. Is around, for example, like when we do tunneling, demonetization, or get into a very hazardous zone. So in tunneling, in this kind of environment, robot may shift the human role from direct execution to control and monitoring and intervention. So for example, for tunnel boring machines, automate mechanics will excavate and support the continuous tunneling. Robot may also support drilling inspection after damaging the structure or remote operate the unsafe space. So in this kind of setting, safety improvement will come from distancing worker from the immediate hazard. But however, I would say human accountability remains important. Someone must monitor what's going on, monitor the ground condition. They also need to interpret the warnings, adjust the parameter, and decide when the work should stop. So it's not saying that the robots is completely replacing human as well. I mean, humans still have a very strong role to supervise the entire process. But this is one of another good example to show actually how the robotics is helping to take people out of the loop and replace human just to make the monitoring decision only. Okay. So another finding very quickly is around in the academic studies or even in some of the great literature we discover on online. I would say most of the robotics are still retained in a prototype stage of testing. So that's the reason why you see majority of stuff is still falling under laboratory prototype. There's a lot of them, not a lot of them, around maybe 20% of them are really field tested. And then the balance are really talking about simulation and really conceptual. So yeah, it's understandable why it happens because robotics deployment is not cheap. So unless client will see a clear value on this, they won't agree to do the field testing. But I think in the future, I think we really need to tie up this kind of things together. Once you get out of the laboratory prototype, I mean, it's reasonably to test it out to the field and try to show it off to the client. And I think that is a lot of work should be done across academia back to the industry as well, so that what we are trying in our research could be something the field is also interested to adopt and test it out further. So I think that link is still not very solid nowadays. That leads to a lot of things is still staying in the prototype stage. Okay, so I think I covered this already. Is around the deployment readiness, cutting across the different life cycle. So this is just we literally, we are not doing much around planning and maintenance, demonetization, while it's relatively mature when we're talking about the construction stage. So a lot of work we should go down to the line to make a bit more focus on maintenance and demonetization planning as well. Okay, so then we will move on to take a look at human robotic collaboration and some cases of that. So let me dive into the detail of this. All right, because in construction, it's very different. As I mentioned earlier, when we compare construction with manufacturing, construction, the environment is very dynamic and is still very labor intensive. So it's not very easy to say, oh, we are going to do a fully autonomous, maybe, I don't know, 20 years later, 30 years later. Maybe, yeah, maybe we will turn around one day, but it's at least not 5, 10 years. So that means even though we try to adopt more robotics on the site, human is still playing a role into the collaboration. That kicks off what we call human robotics collaboration. And then when we look at the human robotic collaboration, we will define the role of human into 4 different levels. So starting from being an operator, so what that means is the human will directly control the robot. So the robot is as an extension of human capability. So for example, a human will remotely control a robotic excavator. So the human is still the controller, not the robot is operating by itself, right? So under this situation, human is classified as an operator. Then the second level, the next level we will look at is human. The role is being a teammate. So what that means, it's the human will share the task with robot. So for example, a robot arm may assist with lifting or braid laying, let me put it this way. So a human robotic arm may assist with lifting, or a braid laying robot may help the work, while humans are supplying the materials and monitor the quality. So they're doing the work together. So under this situation, the level of human robotic collaboration we will classify as teammate. Then the next level is supervisor. Mainly the human, they are just monitoring. Okay, they're monitoring the robot, what they're doing. That could be the robotics already automate. It's fully automate by itself, but you still have the human to stop it, to start it, or where to put the stuff. And then the intervention, the role of the human is they just need to intervene if there is anything wrong. And this is quite common. You can imagine something like the drones that I was talking about flying around doing inspection. Okay, so we are more the supervisor role, but the main task actually is carried out automatically by the drone. Last but not least, okay, if there's one day comes, okay, we are just bystander. So that means we are just present near the robot, but we are not directly involved the task. The role is still, the human role is still important because the construction site is, as I said, is still a quite kind of a very dynamic environment, and work is still affected by the robot movement, even when we are not using the robots. Okay, so this is in a more higher level, which the robots can do most of the tasks, and then even though we don't need our supervision anymore, they know what they are doing. Okay, so those are just the taxonomy. Okay, there's so many different taxonomy, how to classify human robotics interaction, but we just use one of those, okay, and then crystallize it down to what I present to you today. With this taxonomy, we also go ahead to look into what is the current human robotics collaboration pattern in construction. As you can see, actually, our majority is still under the operator level. All right. So what does that imply is this reflect the technical limits, so safety demand or the need for human judgment in changing the site condition. And then that's why humans still are the dominant who control how the robot is working. And then followed by, actually, there is also a substantial amount of robotics being work as teammate with human being, while far less you will see we can use it as bystander. That means we don't need to really supervise the performance of the robotics. There are around maybe 8.3%, okay, of work. I mean, among the papers that we review, we realize they are in this stage. So what that implies is, as I talked about earlier, that implies we are still, the human role is still very significant in terms of applying robots. We are not yet there to talk about the site could be fully optimized by only robots on the site. So this one, just try to explain a little bit more why operator control remains dominant in construction. But I don't think you'll be surprised by those reasons, to be very honest. But I just go through them quickly. Because why is operator led? It's mainly because the site is very unstructured. Robot is struggling with those changing landscape or the changing dynamics on the site. Okay, we don't have that type of robot. I think in the very near future, the more humanoid type of robot could possibly turn around the situation. And then the second reason is because of the safety accountability remain with human and organization. So if a robot contributes to an unsafe event, the question is responsibility. It won't just disappear. Okay, then who is who is responsible? Is it the company? Is it the people, the human who supervise the robot, etc., etc.? So there are concern around the safety accountability. And then another reason is the interface, okay? The interface of different, let's say if, because I do get some comments, okay, from the industry, particularly if they try to introduce a few different types of robot on the site, they all complains about this. The interface among those robotics is not straightforward. So what that implies is if you use drones, okay, to collect data, then you need to go for platform A. And then your B model is on platform B, okay? And then later on, if you want to have another robotics, okay, like laying, okay, that will use another platform C. And then while you try to integrate all those ABC platform together, it takes a lot of time, okay? It's not saying that not doable, but it takes a lot of time. So there's no common platform that different robotics can talk to each other, and then plus our B model. So it's not as straightforward as we may imagine. So I know some construction firm in Japan particularly, they're looking into building a common interface, but it takes a bit of time, all right? It's not easy as well. All right, and then finally is related to accountability is around trust and certification. It's not yet really developed. Workers and managers, they still need more evidence before they really delegate the completely control to the system. Although we have different ISO talking about robotics, but it's not really geared towards, for example, construction. They are more geared towards manufacturing, given that robotics application is far more developed there. So yeah, we don't have all this. Okay, that all makes us to be a bit skeptical on the robotics application. And at the end, we become more operator control. All right. Okay, so quickly run through a few of them. In terms of how humans interact, okay, involved in those different cases. This is related to the previous example I showed you, okay, we use robotics in tunnel. So the role of human basically around monitoring, okay, telling them when to start, when to stop, all right? And when you move on to take a look at another case around monitoring and sensor installation, so what they are doing is the problem is, for example, a robotic system could be automatically deployed. Okay, it could be drone, it could be the robotic dogs to collect the data. And then, of course, humans still need to control when they will deploy, when they will come back, and how we will analyze the data, and then when they can do more, when they could do less. All right, so that is a human piece, definitely, for this case. And material handling as well. You can only ask the robot to transport it from A to B, and then still human is the actor, the agent, to use the materials to do the task. Of course, in the future, maybe we can argue, okay, that will hand out to another robot to do another task, okay, follow on, okay, but this is a different story. Nowadays, it just helps us to transport the robotics without doing anything further. Okay, so those are the three different cases, how human actually interact, okay, with robotics. Now we can talk about some of the obstacle around why robotics are still not being deployed a lot, even in developed country, even in the UK, to be very honest. Japan is a bit more advanced. Switzerland is also more in advance, but UK is really falling behind as well. Those are the common factors actually hinder the industry from going forward. One is the work environment is still very difficult, okay, because of the unstructured work environment. The cost, of course, is very expensive. It's not cheap, and particularly if you are not, you cannot deploy one robotics on one project and afterwards you can directly just ship it to another project, given that different projects have different needs and different clients. Okay, so it's not that easy, that what we call the economic of scales is not yet there. So that makes each time is a new learning, all right? You need to deploy something new, completely new, all right? Most of the time. So the cost is high. The safety and the regulation side is not very clear. Whether they can do it, they cannot do it. So it's a bit vague at the moment. And then definitely worker acceptance is another issue. Construction workers are not trained, okay, on robotics application in their old training. Even for students who are studying civil engineering now, they are not really geared towards, okay, applying robotics in their work. And then last but not least is how to integrate this with the existing workflow. But the issue, I would say, because we never considered it upfront, okay, we just say, okay, let's deploy in the construction stage. So we need to kind of change, okay, the workflow. We already have an existing workflow, and then we try to change it later on, which makes it even more difficult. But if we have that in mind, we want to apply the robotics at the upfront, probably this workflow integration could be a bit better, given that you have the design at the very beginning. And that's also trigger us to one of the projects that I mentioned earlier. We are trying to develop a simulation platform to allow contractors to simulate robotics if you want to introduce robotics on your site, and then based on your workflow and then the building boundary condition of your building, how can we deploy it in a effective way and also in a safe way, so that they can have a simulation platform to play with, to think about that, to regenerate the workflow could be at the front end, instead of wait until the construction stage while you want to deploy, and then you need to change your existing workflow in order to fit into the work process. So all that the reason actually why it becomes so difficult for the deployment. What time is it? Okay, I have 10 minutes more. Okay, so I think we will just go through the future trends, then I will just stop and get any questions if you guys have anything. So after talking about what's going on in the industry and then what kind of challenges actually we are facing, now I will just move on to talk about what kind of future development possibly could take place. So let me see. So the first trend, there are 5 different trends. So first trend is robotics need to develop or need to be used, okay, move out from just doing a single task to be able to perform in a multifunctional task, okay? Because now one robot could probably only do one thing, all right? If the robot is laying bricks, then they're just laying bricks. They cannot do anything more, all right? So it would be, and one of the direction is how can we make it multitasking? All right. So future system could be combine mapping, inspection, or task excavation. It could be mobile platform that carry reconfigure robot arms, or AI assistant perception could help robotics to adapt to the uncertainty side better, all right, so that enable them to do multiple tasks at the same time, and the platform could be a bit more flexible. So the second trend actually is scalable human robotics collaboration. So it's what we call the movement from a more scalable collaboration. What does that mean? Is the future is, if the future is talking about fully automate, it's better to allocate it's better allocation of human and robotic capabilities. So in some tasks, maybe human will remain as the operator. In the other tasks, robot will become teammate. But in more structured tasks, human may just become a supervisor who intervene whenever that is needed. But the design challenge is the adjustable the autonomy. So the system needs to allow human to remain meaningful in control when uncertainty or risk or accountability requires it. So this is particularly important in construction because conditions change very quickly, and safety critical judgment is often context specific. Okay, so that is the design challenge we need to, probably we can work out more around that. And then the third challenge is around simulation, digital twin, and the industry metaverse. So what does that mean is before robot work next to people, the workflow should be stress tests. So for example, that's the reason why we try to build a simulation platform I mentioned earlier. So because simulation can help to identify human robotic conflicts points, it can also test emergency procedure. It can also train operator. It can also compare alternate site logistics before deployment. For example, before introducing a material transport robot, a project team could simulate the routes, crossing the points, loading the area, congestion, and the emergency stops as well. So this is valuable because it allows safety issue to be identified actually before the robot enter into the site. But however, I would say simulation is only useful if it reflects the real site constraint. If the site constraints are not really built into the simulation, if the simulation won't be anything useful as well. Okay, so whether we can load, for instance, the BIM model quite easily to identify those constraints into the simulation platform, that is the real challenge and the things actually even for my team is working on at the moment. Fourth trend is around the life cycle expansion. As I said, it's really focusing on structural construction at the moment. We definitely think more chances could be towards the operation, maintenance, demonetization, as well as planning and design as well. Given that we can take people out of the loop and then they will have less workers particularly involved in those stages, although you will have tenants as well. So that is another thing we need to think about. Last but not least is the safety governance and acceptance. So technical capability will not scale without the standard or assurance or training and trust. Several governance questions remain unsolved nowadays. So what standard will define safety separation between human and robotics, or who is accountable when a robot contributes to an unsafe action? On what kind of evidence is required before a robot is allowed onto a site, or how should the incidents or near misses involve when robots are being reported? So I think the workforce questions are also equally important. How the workers are being trained, how the trusts are being built, and how can we concern about the job addressed. So I think the safest deployment is not the one where workers are expected to simply accept the robot. I think it is where workers understand the system, trust the control, and can challenge or override unsafe operations as well. So this kind of how to make it work in terms of the governance part, I think is a missing part in the application at the current status. So I think the key message I want to deliver today, I think robotics can have the potential to reduce our exposure to risk, improving health and safety performance. But nowadays, because most of the construction robotics are very task-oriented, they are also at a very prototype stage, which is a limitation. So we really need to test it out in the site in order to see whether that really works. And if human robotics is the central piece, as I said earlier, then being operator, being a supervisor role is okay. But I think at the end, we want to move more tasks towards more the supervision stage for humans role. And future progress definitely need to make in the future trend that I mentioned as well. Otherwise, it's very difficult to move the industry to increase the adaptation of robotics. Okay, so I think that's it from me. I think it's just any questions or discussion. Let me come back. Yeah, so feel free to ask any questions if you have any. I think we still have 5 minutes, okay? Although I try my very best to go through it very quickly.
Okay.
Thank you so much, Dr. Clara.
Any questions? Oh, we have a lot, Clara.
Oh my gosh, I thought they're sleeping. Okay, then that's the best session. Okay.
I saw your notes. You have a weekly